Well, it's a pleasure and honor for me to welcome among us Professor Leo Wanner from Barcelona, those who have been present at the first Dependency Linguistics Conference, and those at least read about the conference may remember that Professor Wanner was the organizer of that conference. And I think the conference started a nice series, I hope a nice series of regular dependency linguistic conferences. And I think since then we have been in very good personal relations, and not only personal relations, because I also got the opportunity to read one of the doctoral thesis, which was written by one of these co-authors, by Simon Miller, on generation, on language generation. So I'm very happy that this time Leo could accept our invitation to come here, and I'm also looking forward to his talk on the deep syntactic parsing.
Okay. Thank you very much, Ivana. I'm really very happy to be back here. So I gave a talk last year, 1 year ago, and on a similar topic. Finally, I ended up talking about the same all the time, from different perspectives. Thank you very much for the invitation. So I'll be talking about the common work we did with a couple of colleagues. So first of all, Miguel Ballesteros, who is the deep parsing person in our group, so then Simon and Bernd Bonnet now from Google, and myself. So deep syntactic parsing, I could also say shallow semantic parser with grammatical parsing, whatever. But the point is that it's a little bit deeper than what we usually see with the majority of state-of-the-art syntactic parsers, dependency parsers. Okay, the outline of my talk. So first of all, I'd like to motivate why we need deep syntactic parsing. And there are a couple of applications, there are several applications in NLP which profit from deeper parsing. And one of those applications especially is machine translation, transfer-based machine translation. I saw a poster, English to Urdu machine translation, syntactic machine translation, statistical machine translation you are doing, so you are very much familiar with this issue. So then I'll introduce, although I don't think that it's really necessary to introduce here the notion of deep syntactic structure. I'll give the definition, compare a little bit with the structures from other theories where we are, because quite often when we present our work, okay, so people say, okay, no, but we have the same structure in LFG, for example, why don't you take LFG, So, and we take this deep syntactic structure. Okay, so then I'll introduce the principles of deep syntactic parsing, and this stage of our work, it's multiple stage, so it's a pipeline of parsing from surface to surface syntactic structures, and then from surface syntactic to deep syntactic structures. Okay, so I'll present some experiments we did. So first of all on Spanish, but also English and Chinese, and then their outcome, and I'll conclude with some statements and tell what we're working about on these days. So motivation. So if we look at the syntactic structures as we see them in current state-of-the-art syntactic parsers, so we see something like this. So the structures might deviate a little bit, but in principle we have the grammatical functions here, subject, object, then we have copula maybe, etc. So, and here we see an English phrase. So what's the syntactic structure for an English phrase, and the phrase is he's being the Mary's invitee bothers me. No? So we, okay, wait a second, just his being Mary's NVT bothers me. No? So we see this, and in French, the French equivalent, no? So we have here, qu'il soit l'invité de Marie me dérange, something like this, and we see immediately, no? So there are quite a few differences between these two syntactic structures. No? So, okay, we have here B, and here we have this a relation, no? Que être, no? So then we have NVT, Mary's NVT, and we have here a whole clausal construction. No? So that is, so in principle, no? So we see that the structures, the syntactic structures, are far from being isomorphic. No? So, and this is kind of a problem in for machine translation. No? So if we look at Probank structures, no? So we have something like where A0 is the whole thing. He's being Mary's NVT, and me is the A1 argument. No? And if we in French, we have this chunk, the whole chunk of meaning, not just one, let's say, one unit being subsumed by an argument. No? And this basically the same, but with different labels. We have at the in FrameNet. No? So we have stimulus here, something. Then we have the lexical unit, the disambiguate lexical unit, and we have the experience here. No? So, and basically the same, no? So this is mirrored, no? From the Probank structures. No? So that is, if we look at the syntactic structures as such, no? So they tend to encode idiosyncratic linguistic constructions of the source language and of the target language, which is obviously not very good for machine translation. For, let's say, straightforward machine translation, you need to cope with the differences in the structure. And if you look at the Probank structures and the same, basically, FrameNet structures, so they subsume the whole chunks of meaning. No? So that's not just unit by unit, and this means that if you want to translate, now taking Probank structures or FrameNet structures into account, so then it's getting, basically it's a mess now. And obviously from the formal point of view, these are forests, so that's not necessarily one connected structure. Just you get, especially if you look at Probank, no? So there is a tree, and there is another tree, no? Which represents fragments of a sentence. That is, if you want to go through, no? So if you have an algorithm which traverses this structure, so then you don't know what fits where. No? So this is a problem. And they continue to be idiosyncratic, although they are in a sense, no? So they carry, let's say, semantic roles and are supposed to be semantic. No? Okay, so that's, as I said, now FrameNet structure, that's basically the same. Okay, now, and if we kind of think about transfer-based MT and where statistical machine translation goes, so we are trying to, let's say, arrive or handle structures which are more or less isomorphic, no, between languages, as isomorphic as possible, no, so as common as possible. So then, obviously, no, so our algorithm has less chances to get something wrong, no. So, so we need something which is syntactic in its nature, no, so still not semantic, because we don't want to that's for us that's too complex to go to semantics if we want to do machine translation. No, we prefer to stay at the syntactic level, but the structure ought to be abstract enough to abstract away from such idiosyncrasies as we saw with English and French. No? So that it has, not just for easier handling, that it has a language universal arc vocabulary, is connected, no, and what we arrive at, no, at least no, in our framework, No? So this is the deep syntactic structure. No? So obviously there are others. No? The grammatical, as I will mention later on, grammatical structure is similar, but we are working in the framework of the meaning text theory, and there we find the deep syntactic structure, which fits our needs here. So just a formal definition, just to know what we are talking about. A formal definition of what a deep syntactic structure is. That's a quintuple with, basically it's a dependency tree where the node labels are only full lexical units. So that is, we don't have any functional words at this level. And we have only this restricted repertoire of relations. So that's argument or valency relation, then we have an attribute relation, coordinate relation, and append relation. No, so that's all. No, so basically we have here, well, okay, 6 at most 6, and then those 3. No, so 9 relations. No, so that's, and they the theory claims that those relations are universal across languages. No, so you can use 1, 2, 3, no, to label arguments, whether it's Arabic or whether it's English or whether it's Russian or Czech. Okay, so here we see such a structure. So and maybe here this is a little bit more illustrative. What we saw before, the surface syntactic structure with the example sentence with his being marries in VT bothers me now, and qu'il soit l'invité, no? So in French, now we have absolutely the same idiosyncratic, let's say the same isomorphic structures for English and for French. That is, we keep the meaning, but we abstract away from the idiosyncrasies, no, of the languages. No? So, and this is actually what we like. No? And here we have also grammemes or grammatemes. No? So at this level where, let's say mood, voice, tense, etc. No? Okay, and just a very brief comparison where we are, no, in the landscape of other theories. No? So as I already mentioned, so quite often people say, hey, the F structure in LFG, that's basically the same. You don't need something exotic or kind of weird like a deep syntactic structure. No? So why don't you take the F structure? No, but as we will see in a second, no, so the F structure is much more surface oriented. It's basically, it compiles. No, actually, nowadays LFG is a little bit similar to HPSG. No? So they pack a lot of stuff, no? Semantically oriented and syntactically oriented, morphologically oriented, into the same F structure. No? So HPSG structure is hybrid, but it also contains, let's say, surface syntactic information. And what I think that, I'm not sure, but I think that it's most similar to the tectogrammatical level of representation, no? So the deep syntactic representation. And if I'm not mistaken, there was already in 2008 or a little bit later a PhD thesis on tectogrammatical parsing here. No? So it's so we are not the first, no, to do this. Okay, no. So here, just for as an example, this is the sentence, the F structure for the sentence. His being marries in VT bothers me. You know, from parsed by the paragram system. Now, in here we see all the, let's say, morphological information. We see the syntactic information. We see the let's say semantic information. No, so that is the F structure is not, let's say, equivalent to the deep syntactic structure. No, so it's if you wish, it's much more, and it's also a little bit less. No? Okay, so now, so this is basically the framework. No, so we're kind of moving in. and our parsing model. No? Our parsing model is basically the simplified meaning text model, where we have, and we kind of concentrate on those three layers. No? So we have, no? So here an example that we already saw, an example of a deep syntactic structure, of a surface syntactic structure, and then the morphological, or let's say topological structure. No? So, and we want to be able to cope when parsing, we want to be able to cope with those three different types of structures. Yeah? Okay, surface parsing, as I said before, so we are doing it not in one shot, as some people do, no? So we try to do, no? So kind of surface and then the target structure. So what we do is we have a surface parser, and then we take the output of the surface parser and apply the deep parser, the deep syntactic parser to it. Yeah. So first for practical reasons, and then for also for maybe theoretical reasons. No. So where you say, okay, no. So it's linguistically, it's not very meaningful to do it in one shot. No. So why do we have those layers? You know, when then we don't pay attention to them. No, so we want to go step by step. No? Okay, so the surface parsers, as we have them basically, you know, so everywhere, dependency parsers. So what they do is they take a chain of lexical tokens, you know, so that's a sentence, and they create dependency tree. But the important thing is that this projection is isomorphic. That is, you have the same number of nodes in the chain that in the tree. No, so and all the the vast majority of the algorithms they require, no, so this isomorphism. No, so that is yeah, as I said, the number of tokens is the same. No, a token corresponds, no, so the labels basically correspond. That's less important, but still, and the task basically consists in converting a chain into a hierarchical dependency tree, no, no, and enrich so the tokens by morphological information. Obviously. Okay, no, so here also kind of if we want to, I don't think we need to go through this definition, but basically we have at the surface syntactic level we have all lexical items, be they functional or be they full, and we have those grammatical functions, subject, object, whatever, no, depending on our annotation scheme from 60 to, let's say, 15 labels. No, depends also what we actually want. You know, and okay, so here, but if we, no, let's assume that we have this syntactic structure, no, surface syntactic structure. That's basically, you know, so what all people do. So we can use one of those parsers, and what we ought to do is to start from this structure, no, and get to this one, no. So that is, here we have the a projection which is not isomorphic, obviously. No, so we have John corresponds to John, so that's fine. No, but we have here say that, and here we have only one node. No, so as we had basically, no, a little bit similar what we had before, and we have B persecuted and persecute here again 2 to 1, and we have student and this student, because here we get rid of the functional, the determiner node, no, again, no. So okay, no, so this is the problem basically, no. So we have trees. We want to get from this tree to this tree, and they are not isomorphic. How can we do it? No, to make it reasonably simple and still kind of not lose any information. No? So, okay, so let's first study a little bit what kind of correspondences we have in more detail. No? So we had kind of nodes or a couple of nodes corresponding to one node, etc. No? But so if we want to do this projection, we need to know exactly what we're speaking about. No? So here we have once again we have the same surface syntactic tree, only a little bit turned a little bit graphically in a different way. Here we have the let's say grammeme information, and here we have the corresponding deep syntactic tree. No? And again, with the information assigned, the attribute value pairs assigned to student, to this node, and here to student as well. No? So we have basically a node corresponds to a node in the surface tree corresponds to a node in a deep tree. No? So this is our, let's say, lucky case. No? So for example, say corresponds to say. There's no complication about it. Then we have a relation is a relation in the surface tree corresponds to a relation in the deep tree. Again, no? So this is our lucky case. Yeah? But then we have a subtree, and the surface syntax corresponds to a node in the deep tree. No? So the case we had before, here B persecuted, and here analytical passive. No? So this corresponds to persecute. Then we have a relation with a dependent or governor, no? Is a grammeme, no? Or grammateme in the deep tree. Now, for example, here we have this, the determiner here, no? And this becomes an attribute value pair. And we have the correspondence between grammemes, no? So we have singular and singular here, and we have, in Spanish, we have two other cases, no? So this a node is conflated. This is when we have a reflexive, no? Say the particle se, no? Dirigirse, no? So direct yourself to someone, no? So these are two nodes, and then they are conflated at the deep syntactic level, and we have a node in the deep tree, and there is nothing in the surface tree. No, so this is common to all pro-drop languages. No, so we have those 7 cases. No, and some of them are uncritical. No, some of them are a little bit more critical. No? So okay, how we do it? No, so the idea is really very, very simple. No, so we say okay, we look how people in the graph theory are coping with those cases, and they cheat a little bit. They introduce so-called hypernodes. No, so that is, we pack everything which is, let's say, which disturbs the isomorphism, no, we pack into one node, no? And then we'll see how we deal with those complex nodes. But first, we want to have 2 isomorphic structures, no? So to be able to apply our standard algorithms, no? So and okay, so the hypernode is nothing else than a partition of nodes where can be one or more nodes, no, which corresponds to one single node in the equivalent tree. This can be at the surface level. This can be at the deep level. No, yeah. So it's always more in the let's say John case. There are 2 hypernodes of cardinality 1. No, so if we have here this hypernode here, there no, so we have a hypernode of cardinality 2, and here 1. No, so it's just we kind of basically, as I say, we just pack whatever disturbs us isolate into single nodes. No, and then basically we can handle this problem in a very straightforward way. No, so first Now, if we want to do deep syntactic parsing, first, we do the surface syntactic parsing. We take an existing parser. So then we identify the hypernodes. We construct the deep syntactic tree. And then, we label, introduce labels, and we do some post-processing, whatever is necessary. No? Okay, so and here, this is the setup of our experiment. So for surface parsing, we took the parser by Bernd Bonnet and Joachim Nivre, so which is quite competitive, and then its output is then fed into our surface syntactic, deep syntactic parser. So, and there's basically a cascade of classifiers support vector machines. And post-processing, this is, we'll see in a minute, that's just a rule-based add-on. Okay, so experiments we did on Spanish, we did with a very small, we can say, corpus. So, basically very well revised. So that's only 3.5 thousand sentences with a small development set. And so here we see the difference between the number of tokens in the deep syntactic level and at the surface syntactic level. So it's okay. So the test set, so that's deep syntactic is reduced basically by 3,000 nodes. So that's generalized. Okay, so how does this work? Not just a very simple illustration. If we have something, the sentence, the cat looks at her. So first, what we do, the surface parser. So we create the surface syntactic structure. So then comes the hypernode identification or clustering, as I said. So the cat goes into one. So look at goes into one. So it's but we still have the surface syntactic structures. So then we get rid of the functional nodes. And here, finally, we introduce, we substitute the relations, the surface syntactic relations by deep syntactic relations. And in this rule-based post-processing, we introduce the correct, so morphological, morphosyntactic information. Okay, so as I already mentioned, the surface parser we use, so that's the Bonnet-Nivre parser, and it's a transition, just for those who are working on parsing, so it's a transition, well, actually, those who work on parsing don't need this introduction. So, it's a transition-based parser, and it's a joint part of speech tagger and parser. So it uses a beam search. Okay, so it's a little bit too much of detail, but the important thing is probably so that it gets this this performance. The labeled attachment score is about 81.4, and the unlabeled attachment 88. So this is on our, let's say, on our corpus. Okay, but I think that, well, the principle we could use any other parser who can be trained on our on the corpus, on the surface syntactic corpus. Okay, so the hypernode identification is basically a binary classification. So first we have a class of hypernodes with of cardinality 1 and hypernodes of cardinality more than 1. And this is the cardinality 1 we have if we have a noun, so there will be always without a determinant, it will be always a hypernode of cardinality 1. So if we have a verb, it will be always a No? So, but then there are cases, specific cases, where we know it will be always, no? So cardinality more than one. Okay, so we take, for this classification, we take an off-the-shelf support vector machine, and we use this kind of, maybe interesting, what kind of features we use. No? So we use the lemmas, we use the relations. No? So the usual stuff, basically. No? Okay, and the deep tree construction, the second step. No? So it's boils down basically to 3 different cases where we have, no? So both nodes are projected onto the deep level, no? So then we just connect them. So then there is we have one of the nodes, or the antecedent, or the answer is not projected. So then we have the case where there is one option we can connect to, no? And this is the second case, and where we have several possibilities, no, to connect. No, we don't know which kind of head, no, what head, no, is actually required here. No, we have several candidates, and then we take the most common one. No, so we look at the corpus and we say, okay, no, it seems that if we connect those 2 nodes, no, so then this is the best solution, no, according to our training corpus. Now, relation label classification. So again, we have 2 different cases where we have a one-to-one correspondence, and we have a kind of one-to-many or more complex correspondences. No, and here, no, okay, no, so for the complex correspondences, for some of the complex correspondences, we use multi-class support vector machine. And here, no, you see, and this is a pretty straightforward exercise where we look at the corpus and say, okay, no, so this surface syntactic relation is always mapped onto attribute, no, at the deep syntactic level. No, so we know that subject is always mapped onto 1. No, we know that this relat, or whatever it's called, is always an attribute. No, so this is one-to-one. No, so there is no magic about it. No, the more complex correspondences here, we know that if we have the this relation, analytical, no, the auxiliary logical future, so then we remove the auxiliary node and we need to introduce the grammeme or grammateme future. No, so if we have passive, we do basically the same, etc. No, here a little bit more complex conditions. No, so and so this is part of some of them we do by classification, but if there is no doubt, no, if it's really kind of so we don't need a classifier to say that analytical future is future. No, so it's just 100%. No, so that's why we have this kind of post-processing stage where we say, if we have the analytical futures, so then we introduce just the grammateme future. No, so we well, those 5 rules, post-processing rules, which kind of cover the, let's say, non-ambiguous cases where we don't, the complex mappings where we don't need a classifier. Okay, so before I come to the results, no, so of when applied to first to the Spanish code, I think it's necessary to introduce a little bit the measures we use. No, and we can't use the standard measures. No, so the labeled, unlabeled attachment score, obviously, no, because our trees, no, so are not isomorphic, they are not ordered, etc. No, so we use more or less precision recall, and some kind of made up measures which reflect a little bit the performance. No? So for Hypernode detection, we have the precision recall and the F measure. No? So okay, no, so precision, so the how many correct hypernodes we got and how many they were predicted. No? So the standard stuff, no? Precision recall. Here, precision of node attachment. So this is, we use unlabeled attachment precision, and this is how many, no? So the ratio between the correctly identified heads with respect to predicted heads. No? So the labeled here, we take into account not only the head with the governing relation, no? So whether it's correct, and here together, no? So the correct head and the government relation or governed relation. Okay, and recall that basically, no? So analogous to precision, no? So just kind of the recall measure. Okay, so and what do we get? No? So we have that with the gold. No? So okay, no? So the question is always, no? If we take an existing surface parser, how much does this parser influence, no, our results? No? So whether we are so bad because we are bad, or because the parser already gave us, no, so structures which were incorrect to a certain extent. No? So that's why we kind of did kind of two evaluations. First with the gold surface syntactic structures, where we know we start from correct structures. No? So then we get the for Hypernode identification. So this works quite fine. So it's also a pretty simple task. So the recall is also very good. So label attachment precision, so 91. And unlabeled precision 80, etc. No, so we see that basically it works quite fine. No, so we are doing pretty well with gold standard surface syntactic structure. No, so if we then take the predicted surface syntactic structures, those we get from the surface parser, from the Bonnet-Nivre parser. So then we see, okay. Here, this still works fine, the Hypernode identification. Here we get lower results, significantly lower results. No? So 68 instead of 91. No? So here 77 instead of 98, and here 80 instead of 92. No? And with the recall, that's basically similar. No? So that is, so we can draw different conclusions out of this. No? So either we try to develop a joint deep syntactic parser, where we do as other people do, so with surface, kind of part of speech tagging and parsing in one shot. So we'll try to get down in one shot, or we try to improve to see what the surface parser does wrong. No? Here for English and Chinese, so I don't think that we can take this very seriously, because the preparation of the corpora, of the deep syntactic corpora for English and Chinese at this stage, now English is different, we have a much better annotation of deep syntax for the Probank, but at that time we had an automatically derived, so deep syntactic structure. And this means, so that the mapping is obviously straightforward, and so then the surface syntax, and this means that the surface syntax and deep syntax in this version are very similar. No, so we don't, for example, we don't get rid of governed prepositions there. No, and this is already a difficult task to kind of yeah. So that's why the results here are much better. No, so we'll see how. No, so we will perform when we apply to a realistic, well-done deep syntactic corpus of English. Okay, conclusions. I think that it's well, deep syntactic structure is more appropriate and is more adequate for a couple of NLP applications. First of all, also kind of for machine translation. No? So we should try to do machine translation at the deep syntactic level instead of the surface syntactic level. And but this requires obviously that we have a deep parser and we have a deep generator. Yeah? So we already reversed. So the parser, and we do generation with it, and it works actually even better than parsing. No, so it's the generator is quite good. No, so we actually now we have those two, let's say, modules necessary for the transfer at the deep level. No? So the next step will be basically try machine translation at the deep syntactic level. Now we have kind of rather good quality, at least and with Spanish, no? So realistic quality, and we can bootstrap, no? So the deep syntactic corpora, although we need to be cautious about it, no? So whether we can still kind of say they are genuine deep syntactic, no? Structures. Okay, future work. So we are already into this, no? Into getting a deep syntactic tree bank for English and for Chinese, for German, for working in the framework of a European project. So this will help. And so what we want to see, you know, so how well we can do when we do a joint parser. No? So a deep parser. No? So as I said at the beginning, from the linguistic point of view, this is not necessarily something one would like to have. No? So contradicts, let's say, a multi-layer linguistic model. But the computational people do it, and let's see, you know, what comes out of it. Okay, so thanks a lot. I think that, yeah, I'm time, more or less. Okay.
Thank you very much for your talk, and now I would like to open the floor for discussion.
So maybe one comment and one question. So we actually ran quite similar experiments with machine translation as what you describe here, and in my opinion, the real biggest bottleneck is really the parser. So actually, no matter how good your translation model is, when the structure is wrong, then it's a disaster, and it's really hard to fix. Even if the reported unlabeled attachment score for English looks very nice for English, it's above 90%. When you apply it on real texts from the translation competitions, it's much lower. So that's what I feel as the biggest trouble in this kind of translation.
Okay, no, the thesis I had in mind, no, you certainly know what I'm talking about. No? Is this on machine translation or parsing? I don't. I had in mind that it's on parsing, but it was actually on translation. No?
The thesis which you probably mentioned by Václav Honečleger or Václav Klimeš from 2008. It's only about parsing, so and we don't use that kind of stuff now. But anyway, I'm just saying that our experience is that parsing is still a real trouble. And now the question. You suggest that actually the isomorphism between languages is one of your ultimate goals at the end. Well, I have very same impression. But when we looked at the real data from a parallel corpus, it seems that the real translators, I mean the humans, don't really keep this condition. They don't adhere to it too much. So maybe 2/3 of relations of edges in the tree could be parallel, but I don't think that more than that. So do you think it's a real obstacle, or can you treat it somehow?
Yeah, well, we had the same experience. So we worked on fairy tales, no? So in this scope also kind of prosody translation and so spoken language. So obviously, no. So it's if the sentence in one language has basically very little to do, no, with the sentence in the target language, so then I don't think that this kind of, let's say, transfer-based approach to machine translation can work. No? So obviously, I don't think so. No? So I think that there is a lot more involved. No? So there is maybe we need then the contextual information. No, cultural information involved into this translation model. I don't know. So it's we had a really very strange cases, no, where the same fairy tale and the same episode, no, in Spanish, is really kind of very different. You wouldn't say it's only the names, no, so of the person involved are the same, but otherwise, no. So it's what is being said in English, in Spanish is said, no. Basically, the same content is communicated 2 sentences later on, no. So I don't know. I doubt that we can put a handle on this with this kind of approach. No, so yeah, but I wonder whether this is really or should be our goal. No, at this time being. No, I think that we have enough to do. No, with, let's say, kind of more or less kind of faithful translation. Let me put it this way. So when narratives come in, no? So then it's this, yeah, it's difficult.
Sasha?
Thank you. Well, I think even with textbook translations, I don't think you can arrive at very similar deep syntactic representations. I was actually wondering about the French and English example, where you showed that the 2 different sentences come into the same structure, arrive at the same structure. There must be other types of sentences where it's just impossible. I remember one example, is someone swam over the river, if it's correct English, and in French it could be something like il a traversé la rivière en nageant, and there must be hundreds of structures like this. And so, so you don't believe that languages should have some common deep syntactic structure? I guess.
What I'm okay, so what the only thing I'm saying, so we can get rid of some problems, of a certain percentage of problems, if we if we do machine translation not at the surface syntactic level, but at the deep syntactic level. No? So I'm not saying that we can do machine translation without any further problem. No? So obviously, no. So if you so we worked a little bit on theoretical level. There's lexical translation, no? So where you really have to know. So traverser en nageant, no, and across the river. So it's basically, no, so there's lexes involved. There's not the grammar, no. So then you have the morphological translation, no. So if you have an aspect, no. So no. So basically, if we speak about morphological, in this sound we're speaking about semantics. No? So this is a very huge and very complex problem. So then the discourse, you know, how you kind of develop a discourse in one language, in one language culture, and another language. No, so there is just no. So I would say no. So the surface syntax is the tip of the iceberg. So we cut a little bit, no. So going to the deep syntax, but we are still far away from being able to translate, no. Really, no, naturally translate one text into another. If it's not, let's say, no, so those parallel texts, no, so where we can say, okay, no, here, no, so that's only the surface syntax. And there, no, even in those parallel texts, the surface syntax will quite often be different, but the deep syntax will be a little bit more homogeneous. No?
Well, if I may, I wonder what would your opinion be about projects that go even deeper, that use semantic structure? There have been a few around, and I just a small remark. When you were talking about those two theories, LFG and HPSG, I think actually in LFG they have semantic structure, which would somehow abstract away from those morphological details and also syntactic functions. So there is one more LFG.
Okay, but this structure, so I got from an LFG person. No, so this
sure. There is F structure, but there is another, at least in theory, there is a semantic structure too in LFG, and in HPSG there is something in parallel, like content is the semantic part of the HPSG.
Okay,
very big structure where you rightly said that you have everything, but you have to pick the right part so that you can deal only with. Yeah. So what is? Why don't you work with semantics? Which would bring the structures even closer.
You're asking why we are not parsing into semantics?
Yeah, maybe. Yeah?
Yeah. Okay. No. Well, I'd like to. No, but here we have. And I hope that we'll be able to do so, no, but at a certain point. But here, no, so the semantic structure is a graph, no, so that is, it's another, we add a dimension of complexity. So the mapping, no, so we have, basically, if we deal with trees, no, so that's easier. If we then have acyclic directed graphs as a semantic structure, so then it will be even more difficult.
Yeah, well, you can have flat semantics.
Okay, then we start cheating, no? So, okay, no, I sure, no? So you could, then, I would say, so then we can sell, and we actually do, we sell the deep-syntactic structure, you know, as a shallow semantic structure. If you then, you have a tree, and so if you then substitute kind of, let's say, attribute, by you inverse somehow, so that you know that it's the attribute node is a predicate, so you still have a tree, and you have a kind of deep syntactic structure.
Yeah, well, what I meant was rather the format of the semantic structure. It could be minimal recursion semantics, or this neo-Davidsonian. Yeah, so things like that.
Okay, okay, so this is maybe ideology, no? So, but Davidsonian semantics to me, so that's not really semantics. No, it's not only predicate argument. No, so you have basically in Davidsonian semantics you have a whole lot of linguistic information and introduced. No? So you have all the, you can have the determiners, whatever, no?
Yeah? Depends on,
it depends,
what you want to.
But the let's say the traditional Davidsonian semantics, no? So you can, if we, if you say, okay, no, so if we restrict semantics to predicate argument structures, yeah, okay, so then I'm with you, no? So then we would say, okay, so we need to reverse the attribute nodes and this kind of stuff. We need to, in order to capture, let's say we don't want kind of determinate information, we want to have, let's say, the information structure, no? So giving you, no, and this kind of stuff, no? So then if we go deep, so we should go deep, no? And this is so scary.
Okay, thank you. I'm sorry.
Yeah, but
thank you very much.
If I understand you well, you have 1 to 6 arguments.
Yeah.
And are there some examples where all 6 are present in data? It's one question. And the next question is, it is possible to have argument 6 without argument 3?
Oof. Well, the first question, okay, so there were some weird examples, I don't remember. But in principle, no, so when I put up to 6, no, just to be on the safe side.
We have 5.
Yeah, yeah. No, so I could say, well, to be more careful, no, so well, 1, 2, ... no. So whatever, how many arguments, this is not important to me. No? So it's okay, I think that I need to look up, I need to ask Igor. No, he is specialist for thinking of weird examples. No? But I think that he had one with 6. And whether you can have 6 without 3, I think it will, in principle, yes. But again, no, it depends on the language data. I don't know, no. So it's and the languages I speak, probably not. But sorry, no. So this is.
Okay. I will tell you why I am asking this. Because in meaning text theory, it is for me shocking examples where are 7 arguments. And this is something as lend. Somebody lends to somebody something, for what time, for which money, and it is extremely broad for me. Therefore, I ask where is the boundary for particular theories?
I would say, no, so well, my personal opinion is, no, if you need an argument for the definition of a lexical unit, so then it is, or you need something no, for the definition of a lexical unit, then it's an argument. If not, so no, if you can say a lend something without, no, for if it's still to lend without saying for how long, no, I think that it's fine. So then it's debatable, no, whether it's an argument or not, I would say, no? So to me, so I would assume this pragmatic, let's say, stand.
Yeah, Marke.
Maybe I have missed something in your talk, so I'm sorry for that. But back to your talk, back to your transition from a structure to surface syntax structure to deep structure. When the nodes which are not present in surface, when they are introduced into the structure, as for example in Czech or Spanish, yes, you can drop subject. So in the surface sentence, you have no subject, and you have to restore it or to add it in the deep structure. I am not sure if you mentioned this. Maybe I just missed it.
Yeah, it's. I didn't mention it explicitly because it's. So this is one of our case. Here we go. No, so that's the seventh case. No? So yeah, so it's done at the rule in the post-processing stage. No, because we know what if subject is missing, so we know what we need to put there. No, yeah.
Thank you. Thank you.
Can you be lexically specific on some verbs may not have subjects in Czech? Is it the same in Spanish? Like it is raining, so in Czech you wouldn't.
Yeah. Yeah, the same in Spanish.
So you have to check whether this verb means something.
No, so it's usually kind of restricted, non-meteorological verbs, so they don't need. In German the same, no? So only that, yeah.
Now I have one very particular question and one just provocation. The particular question is when you gave us the experiments, the results of the experiments, how big the data were on which you made these measurements?
Okay.
On this, okay,
yeah,
okay.
So that's I didn't include into my presentation here the results on the development set. No? So that's on the test set.
Okay, I see it now. Sorry, I missed that. And the provocation concerns function words. Actually, we discussed that before lunch, but it was a private discussion in between the two of us. So I just wanted to provoke you to give some pros and cons of including function words into the annotation schemes.
Okay, it depends, no? Yeah. So I think, I think we agree here, no? So so at the surface level, I think that when we cover all the lexical items, no, but all the tokens in a sentence, so then we need to introduce also the functional nodes, no?
And where to put them?
Where to put them? Because it's for me it's clear, no. So that I mean that is it's so that they govern, let's say an auxiliary governs the main word, no. Why? Because of the agreement, etc. No. So at this is the surface level, no. So and at the deep level, I don't think that we need them, no, because we have this information already in terms of grammatemes, grammemes in text theory, no. So I think that this, and as we discussed earlier on, so it's, I think that this question, this is a question only for theories where you have only one layer of representation. So then you say, okay, semantics is more important, no? So I put the content verb, no, let's say up, and then the functional only is a, no. So as Chris Manning or Joachim also, they say, okay, so this is grammatical information. That's why they put it below, no, as a governed of the content verb. But I would say, okay, so I have a better place, no? So I present it as a grammatical information, as a grammateme, and there it's clear that it forms part of the content, no, token. So there is no need to have a dependency link, no? So That's why I think that for multi-layer models, it's a little bit an artificial, let's say, problem. But it's a very important problem in the computational linguistics community now. So we need to have an answer.
Well, I mentioned it because it's, as you say, it's something which is now discussed very broadly, and it probably will be one of the issues which will be discussed in Uppsala at the Dependency Linguistics Conference. So that's why I just wanted to put it on the agenda.
Yeah,
here.
but I think we all agree, no?
I think we do. Yeah.
How?
It's nice to have a support.
Yeah.
So, any further comment or question to be discussed here? Well, if not, I would like to thank again to Leod for coming here, for giving us presenting us his views on deep syntactic parsing, and I do hope in further rich constructive relations and contexts. Thank you very much.
Thank you very much for your time.